Hello class, today we'll be talking about chapter 10. First, we'll be looking at 10.1, which is going to talk about parabolas. We're going to deal with conic sections. We're going to do horizontal parabolas. We're going to do geometric definition and equations of parabolas. And we're going to look at some application of parabolas. So, first thing we look at is the conic section. So, parabolas, circles, ellipses, hyperbolas, form a group of curves known as conic sections or conic sections. It says because they are the results of the intersectings of a cone with a plane. It says the graph is shown next. So let's look at how they make their different shapes in a cone. So if we look at this first one, we see that we have a plane that is doing what? That's slant with the conic shape, and it makes an ellipse. Now, if we look at the one on the bottom, we look at this one right here. We notice this one is a circle because it's a what? A flat plane, and it's going through what? It's just going around in a circle. Now, let's say we had like a parabola at the edge of the plane. We have what? A parabola. Then we have what? A plane going between both conic sections. So it's going through this conic section and this section. We have a hyperbola. So when we look at this, if you notice, the hyperbola is going to have what? Two different sides. The parabola will have one side, the circle is going to have one side, and the cone, the ellipse will have one side. Now, you probably haven't seen them like this before, but this is where these different shapes come from when we talk about relative to a plane. So, parabola with horizontal axis, all right, of symmetry. It says a parabola with vertex HK and the horizontal line y is equal to k, it says as at the axis of symmetry has an equation of the following form. X minus h is equal to a times y minus k squared. It says the parabola opens up right if a is greater than 0, and it opens up left if a is less than 0. So make sure you write this equation down because you're going to have to use this equation here. It's very important that you write these equations down so when we get to certain things, it'll be easier for you to use. So let's look at something real quick. So it says when the vertex HK is 0, 0, and A is equal to 1, you have Y minus K is equal to A times X minus H squared, and you have what? X minus H is equal to A times Y minus K squared. The equation is Y is equal to X squared, and X is equal to Y squared. This is when you have what? 0, 0 as the origin. So if you look at it, it's what? It's symmetric. So you have your regular parabola, which goes like this. Then you have your what? Sideways parabola, which is your what? X is equal to Y squared, that goes to the side like this. So this top one, as you see, is Y is equal to X squared. Then the bottom one is X is equal to Y squared. And then it's respect to what? Y equals X. So we have the symmetry for Y equals X. Now, let's actually do a problem. So we says graph X plus 3 is equal to Y minus 2 squared. It then says give the domain and range. So the first thing we need to figure out is what the vertex is. Now, remember the vertex is what? HK. Now, in our previous slide, remember it is x minus h is equal to a times y minus k. Now, in this example, we got x plus 3. So if we were to rewrite what we have, it'll be what? It'll be x minus a negative 3 is equal to y minus 2 squared. So therefore, our h would be what? Negative 3. So it'd be negative 3, 2 for our vertex. Now, in this case, a is equal to what? 1. Because if you notice, it's just understood 1 here. So since we know that what? 1 is greater than 0, then what direction does it open up at? From the right. All right? So let's look at this. So we have our vertex, and we have what? We know its direction is opening up at. So now, if we need to find anything else, we just need to find where some points on the map. Some points. So let's look at it. So you graph this just the same way you would graph anything else. So let's look. We will make us a XY table or chart. All right. So we already know one of the things is negative 3, 2. Let's say we put negative 2. So if we put in negative 2, we'll get 2 different answers, right? We'll get 3, and we'll get negative 2 is equal to what? 1. Now, for the people who may be wondering how we got that, let's do this. So when we put this in, we got what? So we just say we put in, I'm going to put in for x. So if I got negative 2, and let me make this a little bit smaller. Negative 2 plus 3 is equal to, then we have y minus 2 squared, right? So therefore, this is going to be what? 1. Then we're going to have what? Is equal to y minus 2, and all this is squared. Now, when I take the square root of both sides, this is going to be, so if I take the square root, it's going to be the square root of 1, so plus or minus, which is equal to y minus 2. So therefore, I got plus or minus 1 is equal to y minus 2. So I'm going to have y is equal to 2 plus 1, and y is equal to what? 2 minus 1. All right, so this is going to be 3, and that's going to give me what? 1. That's how we got the 2 y's of being that. So that's why we got the 2 different ones. Now, let's go ahead and do a couple more. So we got 1, and then when we plug in 1, we get 4. Then we got 1 again, and when we plug in 1, we get what? 0. All right? You go through the same process that you did a few minutes ago. All right. So now let's look at what the domain is going to be. All right. Before we even graph it, let's look at what the domain is going to be. If we know that the what? Lowest x value that I have is going to be negative 3 because that's the what? Vertex. All right. So we got what? From negative 3. So domain is from what? Negative 3 to what? Infinity. Remember, you use a bracket because it's included, and you use a parentheses when it's not included. And you always use a parentheses with infinity. So keep that in mind. Now, if we think about what? Let's say what the axis of symmetry, or the line which is symmetric to. So if we look at symmetry, it's symmetric of y is equal to what? 2. Right? Remember before, when it was the regular, like y is equal to x squared, it was just whatever the x value is it was just your what? It was your h. Now it's your k because it's what? Sitting on the side. So basically the stuff that you already knew about parabolas, we're talking about sideways parabolas or different types of parabolas. All right? So now, let's say if you was looking for range. Now, what would your range be? Now, in a basic parabola, your domain, remember this is what? They're inverses. So if the domain of the standard y is equal to x squared is what? X to is infinity to the negative infinity to positive infinity, then what? If we do the inverse one, then our range would be what? From negative infinity to positive infinity. And I'm going to show you this on the graph next. So you would just graph these things, and you should end up with this. So just like we found out, our domain is what? Negative 3 to infinity, and our range is negative infinity to infinity. So take a minute and look over this graph and see, make sure you can, replicate this. You can actually make this graph. All right, let's look at this one. It says graphing parabolas of horizontal axis. It says graph x is equal to 2 times y squared plus 6y plus 5. Now, when we do this one, we got to do this one a little different. Now we have to go back and find our old math skills that we learned from 171. We're going to have to complete the square. So, if you don't remember how to complete the square, let's go through it. So the first thing we're going to have to do is I'm going to take the 2 out of the first two things, the first two terms. So it's going to be 2 times y squared plus, then this one is going to be what? 3y. Then I'm going to say plus, then I'm going to leave a space, then I'm going to say plus 5. Now, I did not take it out of the 5. All right, I just took it out of the 2y squared and the 6y. So now, I'm about to change in a few colors. Now, what we're going to do now is, to complete the square, we're going to take half of b, then square it. Half of b means I'm going to take half of 3 and square it. So it's going to be half. Now, I'm going to do it a little bit different than the way your book does it. So I'm going to take half of b. So it'll be 3 over 2, and then I'm going to square it. Now, keep in mind what you do on the inside, you have to do on the outside. So this is going to be minus, all right? Now, since we have a 2 here, we have to keep in mind we have to do 2 times 3 half squared. So it's going to look a little different. Now, I went on ahead and used the minus. I put the minus there. Now, you might see them use the minus on the inside. I'm using the minus on the outside, all right? So let's look at it. So if I rewrite this, it's going to be x is equal to 2. Now, when I rewrite this, this is what? Y squared plus 3y plus 9 over 4. All right? And then this is going to be plus 5 minus 2 times 9 over 4. Now, I'm just going through this. I could have easily just went on and wrote it, which this is y is equal to what? 2 times y, and then this should be what? Plus 3 over 2 squared. And then this is going to be plus 5. Then we're going to get this is going to be what? Minus 18 over 4. Now, I could have easily just went on and made this 9 over 2. Easily, right? Because 18 over 4, it reduces to 9 over 2. So let's go ahead and do this. So it's going to be x is equal to 2 times y plus 3 over 2 squared. And this is going to be what? Plus, and then we'll get 2 over 4, which is 1/2, of course. So now I'm going to have x minus 1/2 is equal to 2 times your y plus 3/2 squared. Now we know we can go ahead and find what your vertex is. So your vertex is going to be 1/2 and negative 3/2. All right. So when we look at domain and range, now we got to look at A. A is what? Greater than 0, so it still opens up from the right. So we know that it's going to open up from the right, and now let's go ahead and do domain. So your domain is going to be what? 1/2 to what? Infinity. Your range is still going to be what? Negative infinity to positive infinity. Now, all you got to do next is just graph all these things. So you already know 1 point, which is what? 1/2 and negative 3/2. And you just got to find another point that works. So let's look. So, as you see, an intersecting point, now you know it's below the what? X-axis. So an intersecting point is 5, 0, and you will get 5, negative 3. Now, you'll be like, how do you find that? You start plugging in different values. All right? You plug in different values and you'll get different results. Now, you don't want to have to plug, you want to see which one can give you a whole number. So if you have a graphing TI-83 or above, what you do is you put it in the calculator. All right? You got to put it in the correct way. All right? And then you get each side. Now, or you can make your XY table and then you start plugging in different values. So keep that in mind. Now, I would say go ahead and start plugging in values for Y instead of plugging in value for X. It'll be a lot easier that way. All right? So make sure if you have any questions, you let me know.